Okay, today's bell work is going to deal with the Pythagorean theorem. So right here on question number 1, we've got 7 for one leg, 11 for the other, and x is the hypotenuse. So remember, when you're using the Pythagorean theorem, a squared plus b squared equals c squared. Remember, c has got to be the hypotenuse. So make sure that you're always squaring the hypotenuse for c, and then the other two are your legs. Okay, so if I set that up, it's going to be 7 squared plus 11 squared equals x squared. And then you'll go ahead and go to your calculator and figure out what x is going to be. So let's go ahead and put that in. So x is going to turn out to be the square root of 170. And we'll just go ahead and leave it like that. Over here, we've got 30, 16 for our legs. X is the hypotenuse. So once again, we've got 30 squared plus 16 squared equals our x squared. So we'll go ahead and type that in, see what we come up with. So we're going to have x equals the square root of 1,156, and that turns out to be 34. All right, this next one, we have the hypotenuse. So remember, the c has to be the hypotenuse. So x squared plus 8 squared equals 17 squared. And then when we solve that for x, you're going to end up subtracting the 8 squared. So x is going to turn out to be the square root of 17 squared minus 8 squared. So 225, and then you're going to take the square root of that, and you end up with 15. All right, over here, same thing, x squared plus 9 squared equals 24 squared. And we'll just solve that. So just for the sake of time, I'll just put the answers up for the other three. Okay, so there's our answers for those last three. I won't work through those. It's just more of the same of what we were doing. Okay, these right here, you're going to have to draw a picture. It says find the diagonal of a square whose perimeter is 40 inches. So if you draw yourself a square, put the diagonal in. When you put the diagonal in, that's now going to be a 45-degree angle, and this one's a 45-degree angle. And it says the perimeter is 40 inches, so perimeter is the distance around, so that would mean each side is 10. And if you do the Pythagorean theorem to find the diagonal, we'll call that x. It's going to be 10 squared plus 10 squared equals x squared. So combine those together and you end up with x equals 10 square root of 2. Okay, number 8, find the length of the diagonal of a square whose perimeter is 28. So same thing, draw ourselves a square. If the perimeter is 28, that means each side is 7. And if we do the Pythagorean theorem, we're going to have 7 squared plus 7 squared equals x squared. So then x is going to turn out to be 7 square root of 2 for your final answer. And then number 9, it says find the height of an equilateral triangle whose sides are 8 inches. So equilateral triangle means all the sides and all the angles are congruent. If you're going to try to find the height, that means I'm going to drop an altitude down, which means this is going to be 90 degrees right there. This side right here is, it says the sides are 8. When you drop the altitude down, it bisects that base, so that side is 4. Now I can do the Pythagorean theorem using just this triangle right here, and then I can figure out what x is. So x squared plus 4 squared equals 8 squared. So x squared equals 8 squared minus 4 squared. So x is going to turn out to be 4 square root of 3 when it's all said and done. Okay, over here, find the height of an equilateral triangle whose perimeter is 12 feet. So if perimeter is all the sides added together and it's 12 feet, then that means each of those is 4 feet. So when I drop the altitude down, it bisects, so this is 2. Pythagorean theorem again, so x squared plus 2 squared equals 4 squared. So x squared equals 16 minus 4. So x is going to be the square root of 12. So that's going to turn out to be 2 square root of 3. Okay, so these last 4 questions right here are kind of the lead-in to what today's lesson's about. So today's lesson is going to be on the special triangles, the 45, 45, and the 30, 60, 90. And how we come up with those is from the square and the equilateral triangle. Okay, so just some quick review here. When we're simplifying radicals, remember, you're looking for a perfect square factor. So if my calculator won't do it for me, then I'm going to have to do it by hand. So I like to look for a 4, a 9, maybe even a 25 or 100. Those are pretty common factors for me, and those are numbers that I know the square root of. So 20, I can tell, is the same thing as 4 times 5. And so I know the square root of 4 is 2. So if I know the square root of 4 is 2, then that means you're just left with square root of 5. So your answer, square root of 20, reduces to 2 times the square root of 5. So you're trying to look for a factor that you can take the square root of to reduce your radical. Okay, so here's a list of these. You can type them in your calculator or you can work them out. I'm just going to put the next slide right here will show you the answers so you can see if you did them right. So here's the answers. And then this one says, not all radicals can be simplified further. Why not? Well, square root of 10 doesn't have a perfect square factor in it. Its factor pairs of 10 are 1 and 10 or 2 and 5. And none of those are perfect square factors. Same thing with 21. It's 1 and 21 or 3 and 7, and there's no perfect square factors in that. So those are simplified. Square root of 10, square root of 21 are simplified. Okay, rationalizing. So when we're working with radicals, we don't want to leave a radical in the denominator. So to rationalize those, we would multiply by whatever's in the denominator. So if it's the square root of 3, multiply the numerator and the denominator by square root of 3. You're not changing the value because the square root of 3 divided by square root of 3 is 1. So it's kind of like you're multiplying by 1. It's what I call a disguised 1. So then you just go ahead. This will turn out to be square root of 3 over 3. Over here on the one on the right, the 4 in the denominator is okay to have. It's just the square root of 6. So we need to rationalize the square root of 6. So we're going to multiply square root of 6 divided by square root of 6. So that's going to turn out to be 5 square root of 6 over 4 times 6. Well, you're going to want to go ahead and multiply that out. So 5 square root of 6 over 24. And that's your answer. Okay, so here's some for you to try. And here's the answers. Okay, so now we're going to go ahead and talk about our first special triangle, our 45-45. It says, what kind of triangle do you get if you draw a diagonal in a square? You get an isosceles triangle, and these base angles right here, we'll call them 45 and 45. So those are 45 degrees apiece. So it says, let's find the hypotenuse of each of the following. So this one is 45 degrees here and 45 degrees here. So when I do the Pythagorean theorem to find my hypotenuse, it's 8 squared plus 8 squared equals x squared. So x is going to be the square root of 8 squared plus 8 squared. And that's 128. And so if you reduce that radical, you end up with 8 root 2. And then over here, same thing. Since this is a right triangle, the legs are the same. So it's isosceles. So that means this is 45 and 45 degrees. So if I want to find the hypotenuse, Pythagorean theorem, 3 squared plus 3 squared equals x squared. So x is going to be the square root of 18. 9 plus 9 is 18. And then that's going to turn out to be 3 square root of 2. So you're supposed to kind of be seeing a pattern here. It says find a pattern with the ratio of the sides of each triangle. Well, it looks like to me To get the hypotenuse, we have been taking the leg and multiplying it by the square root of 2. So the hypotenuse and the leg have a ratio of square root of 2 difference. It's either square root of 2 longer or square root of 2 shorter, I guess to say. So our ratio there is a square root of 2. So in a 45-45 triangle, when the legs are the same, so this is kind of showing you what's happening here. This is the same as this, so our legs are the same. It's a 45-45. The hypotenuse turns out to be x times the square root of 2. So the hypotenuse is the square root of 2 times as long as each leg. Okay, so it says find the length of each side of the triangle. So this is a 45-45. It's marked isosceles, so that means these two have to be 45 degrees. And if this side's 18, the base here is 18. And we just learned that if I'm going to go from a leg to a hypotenuse, it's going to be the square root of 2 longer. I'm going to multiply by the square root of 2. So it's going to be 18 square root of 2. Over here on the right, the two legs are both 7. So once again, if I'm going to go to the hypotenuse, I'm going to a side that's longer, so I'm going to take 7, and I'm going to multiply it again by the square root of 2. So 7 square root of 2. Okay, on this one, what you're doing, the legs are 3, but this time I know the hypotenuse, and I'm going to a leg. This one's pretty easy to look at until it's 3. What you're doing is you're dividing by the square root of 2. I need a leg that's a shorter value, so I'm going to take 3 square root of 2, and I'm going to divide it by square root of 2, and that's just going to leave me with 3. Some of you are probably just saying, well, just drop the square root of 2 off and you're left with 3. Yes, that's true, but in essence that works because you're divided by square root of 2. So over here, same thing. I know the hypotenuse and I want to go to the leg. I know the legs are the same and I know the ratio is the square root of 2. So I'm going to divide by the square root of 2. So 12 divided by square root of 2. Okay, go ahead and rationalize that. You could do it on your calculator and it'll tell you the answer real fast. 12 divided by the square root of 2 is 6 root 2. Okay. So if you know the hypotenuse and you want to find a leg, divide by the square root of 2. If you know a leg and you want the hypotenuse, multiply by the square root of 2. So basically you just have to decide what your operation is. Do I multiply or divide? And you would multiply if you wanted to make the leg longer, and you would divide if you wanted to make that length shorter. So you'd use the ratio square root of 2. So here's some more. So this one's the square root of 6. And I'm going to the hypotenuse, so that means I'm going to multiply by the square root of 2. Well, square root of 6 times square root of 2 turns out to be square root of 12, which is 2 root 3. And you could do that on your calculator if you needed to, but that's what it turns out to be. Over here, I got I have 20, and I want to go to a leg, so that means I need to divide by the square root of 2. So 20 divided by square root of 2. Well, that just turns out to be 10 root 2. So this side is 10 root 2. Down here, 15 and 15 for my legs. I'm going to the hypotenuse, so that means I'm going to multiply by the square root of 2. So my answer is 15 square root of 2. Last one, I know the hypotenuse is the square root of 10. I'm trying to go to a leg, so that means I need to divide by the square root of 2. So if I take the square root of 10 and I divide it by the square root of 2, that turns out to be the square root of 5. So both of those sides are square root 5. Okay, new idea. So this is our 30, 60, 90. It says, what kind of triangle do you get if you draw the altitude of an equilateral triangle? So equilateral, these angles are all 60. And when you draw the altitude in, it bisects this vertex angle. And down here is 90 degrees. It's marked 90. Okay, so when we do that, when we bisect that altitude and we drop down, so if we're pretending this is our altitude, I would know that this side right here is 8, so this side right here on the bottom would have to be 4. So if you do the Pythagorean theorem, x squared plus 4 squared equals 8 squared. Solve that for x. So that's going to be the square root of 64 minus 16, so that's 48. And that's going to turn out to be 4 root 3. Okay, over here, my hypotenuse is 4, so I know this side's going to be 2. When I drop that altitude down, it cuts that base in half, so that's going to be 2. And then if I do the Pythagorean theorem, once again, x squared plus 2 squared equals 4 squared. So that means x equals the square root of 16 minus 4, which is 12. So that turns out to be 2 root 3. So x is 2 root 3. You can see a pattern here. This one right here, if this hypotenuse is 12, this short leg is 6, the one across from this is 30 degrees here, so this is the shortest leg, 6. So then this one would have to be 6 square root 3. And here my hypotenuse is 2, so that means the short leg is 1. And then that means the side, the leg across from the 60 degrees is 1 times the square root of 3, so that's just going to be the square root of 3. So there's a pattern there with those ratios, guys. So here's the pattern. The hypotenuse and the shortest side are always a half each other. So if you call the hypotenuse 2x, then the short side is x. Or if I know the short side's x, then the hypotenuse has to be twice that. And then if you take the shorter leg and you multiply it by the square root of 3, you will get the other leg. So if I take this and multiply it by square root of 3, I get my other leg. So basically you've got a square root of 3 ratio and a 2 ratio. When you're working with the 30, 60, 90s, you always want to find the shortest side first. Okay, so find the shortest leg first. The ratios are comparing from the short leg. So if I do these two, I know that they're half or double. And if I do these two, then I know that it's either multiply or divide by the square root of 3. So that's why you want to find the shortest leg first. Okay, so here we go on this one. I happen to know the shortest leg first. So if I want to go to here, to the hypotenuse, I know that this is the x leg, this is the 2x leg, and this is the x root 3. So if I'm going to go here, I'm going to multiply by 2. So that's going to be 12. And then if I'm going to go here, I'm going to multiply by the square root of 3. So this is going to be 6 square root of 3. All right, this one I know the hypotenuse. So I'm looking, remember I always want to find the shortest leg first. This is the x, this is the 2x, and this is the x root 3. So if I want to go here, I'm now dividing by 2. I want to find that shortest leg first, so 10 divided by 2 is 5. And then I go to the next leg and I multiply by square root of 3. So this is 5 root 3. Over here, I know the longer leg or the medium side. So I want to find the shortest leg or the shortest side. So if I want to go from here to here, I would divide by square root of 3. And that's going to turn out to be 4. So this side is 4, so that means this one is 8. Because when I go from here to here, I multiply by 2. Okay, here's a few more to practice. So we know we have the hypotenuse here. So remember, we always want to go to the shortest side. So that means we're going to divide by 2 to get to that side. This is 5. And then we're going to multiply by the square root of 3 to get to this other leg. So this is going to be 5 root 3. Okay, over here, once they start turning the triangles kind of funny, and they, I don't always draw the best triangles. You got to make sure you know which one's the hypotenuse. The hypotenuse is always across from the right angle. So this is my hypotenuse. So 15 is not the hypotenuse. So this is the side that's across. 15 is the side across from the 60. So we need to get to the shortest side first, or the shortest leg. So to do that, we need to divide by the square root of 3. So 15 divided by the square root of 3 turns out to be 5 root 3. So this side is 5 root 3. And then we're going to go to the hypotenuse now. So we're going to multiply by 2. We're going to double that. So that's going to be 10 square root of 3. Remember, when you multiply by 2, you only multiply the number on the outside, not underneath the radical. All right, down here, these bottom 2. Once again, this is the side across from the 60. So to get to the shortest side, we need to divide by the square root of 3. So 5 root 3 divided by the square root of 3 is 5. So the short side's 5. So now we got to go to the hypotenuse, and so multiply that by 2. Or double it. So if you multiply it by 2, this is 10. That's your hypotenuse. So over here, square root of 2 is given. That is the shortest side. So if I want to get to the hypotenuse, I'm supposed to multiply by 2. I'm supposed to double it. Well, square root of 2 times 2 is 2 root 2. All right, to get to the other leg here, I'm supposed to multiply by the square root of 3. So if you take the square root of 2 and you multiply it by the square root of 3, that ends up being the square root of 6. So your other missing side is square root of 6. Okay, so with the 30, 60, 90, always try to find the shortest side first, and then make a decision. Do I need to multiply or divide? And are you multiplying by 2 or the square root of 3? Are you dividing by the square root of 3? Or, what did I say? Multiplying by square root of 2. Anyway, you got to multiply or divide by, not square root of 2, square root of 3. Or multiply or divide by 2. So this one has square root of 3 in it, or 2 as your ratios. Okay, so this one, we're just going to kind of work through the triangles until we get the side we're looking for. So I'm going to start down here with this 7. So if this side's 7, it's a 45, 45. That side's 7. So that makes the hypotenuse of this triangle right here 7 square root of 2. Okay, now I'm working in a new triangle. 7 square root of 2 is no longer the hypotenuse, but the leg of this triangle right here, this green triangle. So if this side's 7 root 2, this side's 7 root 2. So to get to the hypotenuse, I multiply by root 2. So it's 7 square root of 2 times square root of 2, which just turns out to be 14. Over here, we'll work with this first triangle right here, this one right here, this green one. That's our 30, 60, 90. So the hypotenuse is 10, so the short side is 5. So this is now 5 square root of 3. Now that 5 square root of 3 turns out to be the hypotenuse of the red triangle. So if I know the hypotenuse, remember we always want to go to the short leg, so I got to divide that by this 2. So that's 5 square root of 3 divided by 2. And then to get to the next leg, we multiply by the square root of 3. So 5 square root of 3 divided by 2 times the square root of 3 is 15 over 2. Or you could write 7.5. Same thing. All right, down here it says, what is the length of the altitude of an equilateral triangle with side lengths of 6 square root of 3? So here's our equilateral triangle. Altitude down here, so 6 square root of 3 turns out to be the hypotenuse. So you're going to cut that in half. So divide that by 2, and this is 3 root 3. That gives me the side across from my 30 degrees, right? And then I'm going to multiply by the square root of 3 to get that altitude. So 3 square root of 3 times the square root of 3 turns out to be 9. So that altitude is 9. So you could check that out if you wanted. You could take 6 square root of 3 and figure out what that is as a decimal. Okay, so 6 square root of 3 should be the longest side. So if you're thinking, is 9 right? I don't know if I did that right. So 6 and then do square root of 3. And as a decimal, that's about 10.39. Okay, and then same thing with 3 square root of 3. If you wanted to figure out what that is as a decimal, that's going to be about 5.2. It's 196, so we'll say about 5.2. And then the third side is 9. So it should match, guys. The longest side should be the hypotenuse. The side across, so that is our hypotenuse, that matches. The side across from the 60 should be the next one. So this leg right here is the 9 is across from the 60, so that matches. And then the shortest leg should be across from the 30, which is the 5.2. That's the shortest leg. So everything matches as far as like angle measures and side lengths go. So you could check that if you're like wondering if you did it right. Just change them to decimals and then compare the lengths. Okay, last one. A man is walking his dog on level ground in a straight line with the dog's favorite tree. The angle of elevation from the man's present position to the top of a nearby telephone pole is 30 degrees. Okay, that's drawn in your picture. The angle of elevation from the tree to the top of the telephone pole is 45 degrees. That's drawn in our picture. And it says if the telephone pole is 40 feet tall, so our telephone pole is 40 feet, how far is the man with the dog from the tree? Express your answer to the nearest tenth of a foot. Okay, so here's the man, and we want to know how far he is to the tree right here. So that's our x. Well, I know since this is a 45-45, and if the telephone pole is 40, then from here to here has to be 40. Okay, so all I need to do is figure out this blue part. Well, if I look at the big triangle, so not the 45-45, but if I look at the whole thing now, this one right here, this whole thing, that's now a 30, 60, 90. So I'm going to draw it off to the side here so we can see better what's going on. This is the telephone pole. This is the 40 feet. Here's the 30 degrees right here. So if I know the shortest side, and this is my 60, and this is a right angle, if I want to go to this side right here, I would multiply by the square root of 3. This is 40 square root of 3. Okay, so let's just figure out what 40 square root of 3 is as a decimal. That's about, so this is about 69.28. So, and we're supposed to go to the nearest tenth. So we'll say 69.3. We'll call that 69.3. So we're saying from here to here is 69.3 feet. Now remember our goal was just to figure out how far the man is from the tree. So let's take our 60, so x is going to be the 69.3 minus the 40. So that's going to turn out to be 29.3 feet. So he's about 29.3 feet from the tree. Okay, we're done. That's our special triangles. 30, 60, 90s, 45, 45s. Just make sure you know what ratio you need and whether you're multiplying or dividing.